Hi everyone, I am Ramesh, Assistant Professor, Department of Mathematics, Dr. SNS, Personal Science, Bangalore. In this lecture series video, we are going to discuss about the transportation problem. Using the transportation problem, we find the initial transportation cost and the initial basic feasible solution using by one of the method, least cost method. In our previous video, already we discussed the initial transportation cost and the initial basic feasible solution using by northwest corner road. Continuously, we discuss another method is least cost method. So what is this method? Here, A, B, C are some of the destination points, some of the origin points here, and P is origin is 50, Q is origin 70, R is origin 80. These are all the some of the quantity of product. And A is a destination, there are 60 product is a demand, and B is 70 demand, and C 70 demand also. We transfer all this product through this cost, and we fill this all the destination product, destination requirements using this minimum cost. First we check whether the given transportation problem is balanced or unbalanced. How we check it? First, what is the total origin? Total origin value is 200, and then what is the total destination value is also 200. So this 200 is equal to 200. Therefore, the given transportation problem is balanced. That is, the total origin is equal to total destination. So these two are equal. 200 is equal to 200. Therefore, the given transportation problem is balanced. Therefore, the given transportation problem is balanced. So if it is balanced, we get a feasible solution. Therefore, there exists a feasible solution. So this feasible solution is find out from least cost method. So we discuss how to find the initial basic feasible solution using by least cost method. So here all the rate unit cost 20, 30, 10, 15, 25, 35, 25, 15, 20, and also the supply and the demand. Already we check it, the given transportation problem is balanced, and now we find the initial cost using by the least cost method. So what is least cost? Among this all the unit cost, we choose which one is least. So among this all the cost, the least is 10. So 10 is very least. And what is corresponding supply? There are in origin side there are 20 product ready for supply, and there are 70 destination side, 70 product or demand here. Therefore, from this 50, we take it 50 product and transfer 50 product, and just we fill the demand. Still we have 20 demand is there. After that, on that way there is no supplies available. Therefore, we cancel the remaining. We block the remaining. So that is the least cost. Next, we apply the same least cost method. So what is least cost here? Among all the costs, which one is minimum? The 15 is minimum. Here there are two 15. So we guess which one is out. Either this 15 or this 15 as our choice. So first, this 15 is in second row, but this 15 is third row. Therefore, we take the priority for second row. So 15. We choose this least cost is 15. Corresponding supply is 70. Corresponding supply is 70, and the demand is 60. Therefore, we take 60 from that 70. 60 from this 70, and just we build this demand. So after that, we have 10 supplies still there. So from this, there is no demand is there. There is no destination demand product, so cancel the remaining. Then again we apply least cost. Among these four costs, again this 15 is least. So there are 80 supplies available, but we need only 70 supplies. So just to fill it, still we have 10 supplies available. Here there is no supply there, so block this. And here there are 10 plus 10, 20 supply is available, but we required 20 demand to fill that. So we directly take 10 supplies and also 10 demand. So just we fill this 20 demand is also there. So these are all the way to find the initial solutions using this least cost method. So least cost method is nothing. Among this all the costs, we choose which cost is least, then apply the rim satisfaction or rim satisfaction. Then we go to the initial basic feasible solution and initial transportation cost. So what is the initial basic feasible solution? That is IVFS. So IVFS is Before that, we go to what is whether it is degenerate or non-degenerate, using the number of basic cells is equal to m plus and minus 1 formula. So number of basic cells means the occupied cells. So these all are occupied cells. Among these all the cells, whether here we have 5 occupied cells, is it enough or we need one more cells? We check it, one more or more than one, we check it. The 5 is sufficient to calculate the initial solution. We check it using the formula m plus and minus 1. Therefore, the number of basic cells or occupied cells are how many cells here? 1, 2, 3, 4, 5. There are 5 cells. Where it is 5. And whether it is 5 or more than 5 or less than 5, we check it the formula m plus and minus 1. M is number of rows. Here we have 3 rows. And n is number of columns. There are 4 columns minus 1. So 3 rows, 3 columns. So 6 minus 1 is equal to 5. So the number of bases cell 5 and m plus and minus 1 is 5. Both are equal. Therefore, non-degenerate solution. Non-degenerate solution. Okay. Next, what is IPFS? Initial basic feasible solutions. Where the cell is, where that occupies cells. That 15 is first row, third column, then it is 50. And second one is second row, first column is 60. And second row, third column is 10. Then third row, second column is 70. And third row, third column is 10. So these are all initial basic feasible solutions. And what is initial transportation cost? Using this multiply this cell with 10. What is the meaning? There are 50 product transfer and the cost of each product is 10 rupees. So totally 50 into 10, 500 rupees we will pay, or 5,000 rupees we will pay. So 50 into 10 is equal to 500. So the initial transportation cost is equal to 50 into 10, that is equal to 500 plus, and 60 into 50. So 60 into 50 is 900. Yes, 900. And 10 into 35 is 350, 350. Then 70 into 5 is 105, 0. Is it? Yes, 105, 0. Plus 10 into 20 is 200. Then the total cost is, here it is, we will find the total, it is 0. And it's 5 by 10, remaining 1, 3, 6, 15, 20, remaining 2, 2 plus 1, 3. So 3,000. That is the total initial transportation cost. So using this method, we find among all the costs, we choose which cost is minimum, and we check whether it satisfies the ring conditions. Then we find this problem satisfies the degenerate or non-degenerate conditions using by number of basis cells equal to m plus and minus 1 formula. So this problem is highly satisfied. Therefore, the given problem is not degenerate. Then we calculate what is initial basic feasible solution, where the occupied cells we write that, and then finally what is initial transportation cost. So the initial transportation cost will be 3,000. So that's all this method.